Hey everyone, I am going to show you how to solve some exponential equations. So if we have exponentials on both sides of our equation, remember introducing a log lets you move your exponent out front. So if we're solving for an exponential, there's probably a variable in your exponent, and if you can move it out front, then you can probably solve your equation. So we're going to try two different techniques and see which one works better, which one's quicker, easier, more efficient, and then we'll try to figure out why. So first thing is I want you to remember some properties of logs. The first one is that if you have log of x, that is the same thing as log base 10 of x. And if you have ln of x, that's the natural log, that's the log base e of x. So we can always write those out. If we have the log, the common log of 10 to the x, remember that is log base 10 of 10 to the x, and we can go and get our x. Same thing on this one, natural log of e to the x. Natural log is the same thing as log base e of e to the x, and we can go and result with the x. These are going to help us. And then the other rule is you can pull the n out front of a common log and the exponent, and then on the next one it works the same. If you have the natural log or any log, you can pull the exponent out to the front of a log of any kind. Okay, those four properties are going to help us when we're solving exponential equations. So solve for x, approximate the result to 3 decimal places. I'm looking at using the natural log of x to solve for 10 to the negative x equals 5. So if I'm using the natural log of x, what I want to do is just take the natural log of both sides of my equation. So it's going to look like the natural log of 10 to the negative x equals the natural log of 5. I can take my exponent, just like I said a minute ago, and move it out to the front of my natural log. And that's the whole purpose why I would bother taking the log of both sides of an equation, is so I can move an exponent out to the front. And the reason I would do that is because there's a variable in my exponent, and that's the only way I can solve for it. So I've moved my negative x out front, and what I have right now is negative x natural log of 10 equals natural log of 5. Remember that the natural log of 10 really is the log base e of 10. And nothing can reduce there because this base for the log e and the base for my exponential don't match. Same thing for the natural log of 5, which I see right here. I can't simplify it at all, but I can use my calculator to approximate those. So what I want to do is divide both sides by the negative natural log of 10. And that will give me, because these natural logs will reduce and my positives will, or my negatives will become positives. And then I just need to calculate the natural log of 5 divided by the negative natural log of 10. And when I type that in my calculator, I get a negative 0.699 if I wait until the very last step to do my rounding. The next problem says use the common log of x to solve this equation. Same equation, just a different strategy. So to do that, I want to introduce the common log. Okay, and what I know for like from the previous problem as well is that I can pull that negative x out to the front. So I have negative x times the common log of 10 equals the common log of 5. Now I know the common log is really the log base 10 of 10 for that left-hand side and the log base 10 of 5. But on the left-hand side, I can see that that's going to go pew, and on the right-hand side, I'm kind of stuck with it. So I can simplify this then, because this the left-hand side is going to pew, and I'll have negative x equals log of 5, and if I multiply both sides by a negative 1, I will have x equals negative log of 5, and when I plug that in on my calculator, surprisingly, it is also equal to negative 0.699. Then that begs the question, which approach was easier? Well, when we did the common log, we were able to get the same answer, but we had more logs that we had to take on the calculator. When we used, oh my gosh, did I say common? When we used the natural log, we were not able to simplify either side of our equation, and so we ended up having to take 2 logs on our calculator. On the second problem, we used the common log, and when we used the common log, it actually matched our base for the log and our base for the exponential matched, and we were able to undo them and get rid of them, which left us a much simpler problem, negative x equals log of 5. I wrote more steps than I really needed to, but we can see that it was a little bit quicker, and I only had to do 1 log on my calculator, which is always a nice thing. So which approach was easier? In my opinion, the second. Because the log base 10 of 10 to the negative x, pew, equals negative x. And that made my job a lot quicker in solving that problem. Okay. All right, let's try another problem. Solve for x, approximate the result to 3 decimal places. So using what I learned on the previous page, I want to see what I can do with these problems. This one, I see the base for my exponential is an e, and that should clue me that using the natural log is going to be my quickest strategy for this problem. I do have a 100 in front of the e, and that bothers me because I need that e exposed, so the natural log of e can be all smashed together. It's got to be the natural log of e to the something for me to be able to go pew. I can't do the natural log of 100 e to the something. It's not going to simplify, but I can do the natural log of e to the something, and that I can do pew and only end up with the exponent. So that's what I need to get to, and I'm thinking if I just divide both sides by 100, that I can get where my e is exposed. So I want to switch to my red pen, divide by 100 on both sides. If I divide 0.08 by 100, that means I'm just moving my decimal 2 places to the left. So on the left-hand side, I will have e to the negative 0.03t equals 0.0008. And you can double check that on your calculator. What I have now is e exposed, and I can put the natural log on it. And when I do that, I have to do it on both sides, right? Because that would keep my equation equal. But now I can see the natural log of e is going to go away because of my property. Natural log is log base e of e. They undo each other. So I'm left with just my exponent, negative 0.03t equals the natural log of 0.008. Oh, I missed one. 3 zeros and an 8. So I'm going to take the natural log of 0.0008 eventually, but I want that t by itself first. So I'm going to divide both sides by negative 0.03, which will get my t all alone. and then I have my t equals natural log of 0.0008, and then divide by a negative 0.03. I get a positive 237.697 if I round to 3 decimal places. Okay, the next instructions say to solve that same equation using Excel. Okay, when I use Excel or Sheets to solve this, what I'm really looking for is this left-hand side. If I put in different t's for it, I want to find the one that gets me close to 0.08. So that's going to be my goal. I could also, before I get started, I could also just move the 0.08 to the left-hand side, which doesn't do much in terms of solving the equation except set it to 0, and it's easier for me to find when I'm right at 0. So I'll rewrite it as 100e to the negative 0.03t minus 0.08 equals 0. And then what I'll do is put in this equation using different values for t, and I'll see when I get really close to 0. And whatever value for t that gets me closest to 0 with 3 decimal places, then I'll know that I'm there. So to start, I need some different values of t. I know that it's going to be around 237, so I'm just going to start with 237 and go to 238, 239, and so forth. And then I can put in the 100. So I have to do the equals first, right? Equals 100. And then times. And then E, when you put it in your sheets, you have to do EXP parentheses, and that'll do a base to a certain power. And so I'm going to do negative 0.03 times, and then I have to click on my X, in this case my T, and then close my parentheses for my exponential, and then remember we are going to subtract off the 0.08. So I should be close to 0, but not quite, and you can see that that's the case. I'll drag these down, and I went negative right between 237 and 238. So my actual 0 is somewhere in between those two, which kind of matches what I know. So I'm going to just select a couple and drag it down so I can show getting closer and closer. So if I do 237.5, I am getting closer to 0, 237.6, 237.7, and you can see I switched negative between 237.6 and 237.7, 237.65, 237. I need to go between 0.65. It needs to be between 0.65 and 0.7, so 0.66 maybe. Ooh, we're getting closer. 237.67. Still getting closer. 237.68. 237.69. Okay, so we know we're between 237.69 and 237.7. So maybe 237.695. And we're still good. 237.696. 237.697. 237. Oh, it went negative there. 696, 697. So there's 3 digits it's in between those two. I could do one more digit, 237.695, and see what we've got going on there. And we're still on the positive side of 0, so we would be able to round that. Oops, what did I do? 237.6965 is what I wanted to show. And that's still on the positive side, so we know it's going to be. So if I look at 237.6965, I'm still on the positive side, and then 237.7 is negative. So I know I'm going to be 5 or greater, and so this will round that to a 7, so 0.697. So that's how you can do it, just by zeroing in. But remember, now we know that logs undo exponentials, and so if we got down to this point in our equation, we can use that to help us. So if I want to set it up as t equals this bunch here, then I would say equals the natural log of 0.0008 parentheses, and then divided by negative 0.03, and that was from our equation that we found. And if I push enter, I can get the exact answer there. So if I solve down here, if I were to rewrite this line using t equals, and then in its unsimplified form, it would be the natural log of 0.0008 divided by negative 0.03. And using this form, I can plug it into Sheets or Excel, and you do it by using ln parentheses 0.0008 divided by negative 0.03. If I shift a little bit, you can see that's what we came up with here for the t, and when I plug that in, I get the exact answer. Example 3. Solve for x, approximate the result to 3 decimal places. I have a base to a power, another base to a power. The only way I can get those variables in the exponents to be solved for is if I can make my two bases the same, which 3 and 5 are not the same, or if I use logs. So if my bases were the same, I could just say the two exponents had to be equal. But I don't have that. I have different bases, so I'm going to have to use logs. I can choose one log, which would be maybe a log base 3 on both sides, or log base 5 on both sides, if my calculator handles different bases. But my personal calculator only handles natural log and common log, so I'm going to use one of them. It doesn't matter which one you pick, you're going to have some stuff to calculate. So I will just randomly decide I want to use the common log because it's common, and I'll do 3 to the 2x minus 1 equals log of 5 to the x. Neither of those is going to undo, but the benefit of doing the log on both sides is that I can take the exponent and move it out front of the log. So since I have a log on these, I can move my exponents out front. So I have parentheses 2x minus 1 times the log of 3 equals x times the log of 5. I want my x's by themselves, so the best thing I can do here is I'm going to just distribute. I have a couple of options, but I'm going to just distribute this log of 3. So I'll have 2x times the log of 3 minus the log of 3 equals x times the log of 5. Now, if I wanted to find an actual value for x right off the bat, and I don't care about solving and coming up with a simplified form that is not using approximations, then I could go ahead and put in approximations for log of 3 and log of 5, which is what many of you did on your preparation worksheet. Or I could try to solve for x and keep my logs in the equation and do my approximation at the very end. So a couple of options. What I would like to do here, I think, is show you one way. So if I have two x's in my equation, I need to get them on the same side. So I would subtract that 2x log of 3 from both sides. And when I do that, these will cancel. I'll have negative log of 3 equals, and on the right, those are not like terms. They would have to have the exact same log. This is not. Log 5 and log 3, not the same. But I can just write them as x log 5 minus 2x log 3. And then my next step would be to factor out an x. So I would have log 5 minus 2 log 3. And then I'm almost done because now I have x times a quantity and I want to get x by itself. So I would just divide by that quantity. So both sides by the log 5 minus 2 log 3. And of course on the right, those are the same quantity, one over itself. And I end up with x equals, flipping the whole thing over, negative log 3 over log 5 minus 2 log 3. That's the exact answer. And if I need to approximate, I can do that by plugging it into my calculator. And I get 1.869. Okay, it did say there was another way to do this, and that is to find what log 3 is. And to find what log 5 is. And once you do that, then you can just figure out a little bit quicker. So we would start at this line, 2x minus 1 times, and my log 3 is 0.477. This should look familiar from yesterday for some of you. And then x, and my log 5 was 0.699. And if I distribute here, I'm going to have 0.477 times 2. Or 0.954. X minus 0.477 equals 0.699x. And then now it's a regular looking equation. I have two values with x. I should move this one maybe to the other side. Those cancel. I have negative 0.477 equals 0.255, and then divide both sides. This was an x, and it's a negative 0.255x. Divide both sides by 0.477. Make it a negative. Wrong way. Divide both sides by that negative 0.255. And I have x equals 1.871. Okay, and one thing that we want to notice is that This answer came out, I should say, a little bit different than what we got from this form of our work, and that's because we're doing the log all in one calculation, log base 10 of 3 divided by this difference. So we're not doing any rounding until the very, very end. And you can see when we round early on, like we rounded here and here, our result is going to be off a little bit. So if you want to make sure that your result is exact, then you would simplify for the x equals first, and then do all the logs in one calculation and don't round until the very end. The other thing you could do if you needed to round to 3 decimal places is you would use like 6 decimal places for these two approximations, and then when you multiply and divide and so forth, your result is going to be correct to 3 decimal places. So if you really prefer this second method, go ahead and use it, but start off anytime you take a log, go ahead and write out 6 decimal places and use them in your subsequent calculations, and that should help with the rounding errors. All right, the last thing we're supposed to do is use Excel to graphically solve this equation. I would like to do one thing to the equation first before I put it into Excel, or Sheets is what I'm going to show you, and that is set it equal to 0. So I'm going to move the negative 5 to the x to the left-hand side, and it's going to look like 3 to the 2x minus 1 minus 5 to the x equals 0. And when I graph that, then what I'm looking for is where I cross the x-axis, or where my x causes me to have a 0 for my y. So that's why I'm doing it like that. And if I pull up Sheets here, I can add a new sheet, and I want to find several x values. I know that the one that's going to work is going to be between 1 and 2 for my x, so I'm going to go 0, 1, 2, and just see what happens. So I'll do equals, and I want to do 3 to the 2x minus 1, so I'll say 3 to the, so I'm going to do a caret, parentheses, 2 times, I want to click on my x, and then I want to add a 1. That's my exponent, so I'll close my parentheses there, and then I'll say minus, and the next term is 5 to the x, so 5 to the, and click on my x. And when I push enter, I'm getting a value, and we thought this is exponential, so we do have a tail going off to the left, or to the left for you. So that kind of makes sense to me, so I'm going to drag down. I see a bug. That's supposed to be a minus, so I'm going to fix that. All right, so I am supposed to solve this equation graphically. So what I want to do is, since I put them both to the same side of the equal sign, I'm looking for where they cross the x-axis. I can see it happens between 1 and 2, like I suspected it would, but I want to fine-tune. So I'm going to do 1.0, and then I'll do 1.1, 1.2, and so on. I want to really fine-tune here. So I'm going to select the 2 where I'm going up by 0.1 and get a few of them, and then also drag and drop, or just drag this equation down so that I can see right between 1.8 and 1.9 is where I'm getting to the 0. So if I was going to graph these, I would select them all, insert, and then customization. I'm putting in some titles, so my left vertical is the output. I am going to put a trend line on there just because it should be an exponential, so I'm going to put that on. So the exponential fit is not looking very good because it's just using a single exponential, and we have 2 exponentials with a subtraction in between. So this is how the fit looked, and it was not good. So we should just say none for that, and then we would want to just look. We know that in between these 2 points, is where we're going to hit that 0 line. And so that's where we would search further. So between 1.8 and 1.9 is where we want to show on our graph. So we could insert that one. And then remember, use snipping tool to cut it, paste it to a doc file so that you can print and attach it to your homework. There's another way that you could solve part B using Sheets or Excel, and that is to do two graphs and see where the two lines are equal or where they intersect. And that's kind of fun to see, so I'll show you that one as well. So I'm going to open a new sheet, and on this one, for this column, I'll just pick some values of x, start with maybe 1.0, 1.1, 1.2, and then drag that down. So I'll go between 1 and 2 because I know that's where the change is going to happen. And then for the first column, I'm going to put 3 to the, so it's going to be equals 3 to the, and then parentheses 2 times, click on the x, and then minus 1, parentheses, and then I'm going to tab over and I'm going to say this one is equal to 5 to the, and click on my x and enter. So now for these two, I want to select both of them and then drag them down. And what I'm looking for is where I have the same value for both. And I can see we're getting kind of close right here at about 1.8. And then this one is increasing, and this one is also increasing. So I kind of want to see what happens if I put those two onto a chart. Ooh, that's beautiful. So this is the one I want. And the reason I want it is because where those two lines cross, that's where the two equations are equal. And that's what we're looking for. And it looks like it's happening at about 1.9. That's it for 5.5a. I hope this helps you, and see you tomorrow.